All right, two things. One, I'm looking like that douche who's standing up here on my phone, but I can't see you guys, so I felt like I was more of a douche if I just stared blankly out into the light. And two, I've never worn the Backstreet Boy headphone thing, so you guys will have to bear with me. Normally, I just yell very loudly. All right, so we're going to be talking about speech and language processing today. So if you didn't mean to be here, you lucked out mistakenly. You should just stay, right? It's interesting. I've had a conversation with a couple of people about this talk, about what I was going to do, and I gave the title. And normally I have two things, right? So either they're too young to know who Rosie is, or they know who Rosie is. Never given it internationally, so now I've had to explain that to different people. So if you don't know who Rosie is, there was this cartoon, the Jetsons. They had Rosie was their robot nanny / maid, was super snarky, had a great sense of humor. So if you don't know who that is, either you're very young or you haven't been to the U.S. when that was playing. All right, quick, who am I? Not the existential version, just the really superficial version. I have a blended family. I've got 3 daughters, one of whom's a stepdaughter, and we're all super close. My husband and his girlfriend and my boyfriend, and everybody's just one big happy family. I like to do a shout out to the blended families. We don't get enough cred. I started out at the University of South Carolina, and while I was there, I worked at the Condition-Based Maintenance Center in the Mechanical Engineering Department, and we had the back end of an Apache helicopter in a test stand out on in the parking lot. And so we ran tail rotors and gearboxes to failure so that we could test the vibration signatures and figure out when they were going to fail. So we helped the South Carolina Army National Guard with detecting part failures before they could happen. I was also in the computational data analytics group at Oak Ridge National Lab in Oak Ridge, Tennessee. And I did a number of things there that I can't tell you about. They tell me then I'd have to kill you, but that's not really me, so I'll just not tell you. But I did work for some of the 3-letter agencies, which is what we call them when we want to sound really cool and smart, right? But we worked generally on trying to help them find information amidst a whole lot of information. And then most recently, I was at Dialogue Tech. They are a sort of telecommunications, marketing, data analytics company, and I helped start sort of their data science group, help them sort of integrate machine learning, and my specialization's in natural language processing, so I analyzed call data. And most recently, I've been at PwC, almost hitting 2 months there, so I'm a baby. I'm in emerging technologies, which is a very fancy way of saying I look towards the future to see what is coming up and how can we incorporate that in what we're doing. All right, so it's interesting when you think about AI, right? Because we obviously as humans have a lot invested in what is going to be the future of AI. And obviously our movies are telling a very interesting story, right? Either we're gonna have robots who come out and take over the world, right? Or they're gonna be our best friends who do everything with us and we're no longer gonna need other humans, right? That seems to be the two options. And there's a lot of trepidation, right, behind what's going to happen when we get to this certain point, right? There's this idea of singularity that AI is going to just suddenly start snowballing down, and suddenly we don't have any way of stopping it, and robots suddenly become, cognizant. They become aware. They learn faster than we can, keep up, and they don't need humans anymore, right? And even Stephen Hawking and Elon Musk have expressed some concern that once we get to that point, that there will be the extinction of humans, right? Well, I'm here to tell you I don't think we're there yet, so don't worry. We're not going to suddenly have robots coming in and taking over. But it's an interesting thought, and it's interesting to think about the way that we as humans view robots and sort of where they're going. And today we're going to just talk about sort of the language part of that, where robots are in terms of being able to speak, being able to understand, that type of thing. Also, again, I can't see you, so if you have any questions and you're raising your hand and I'm ignoring you, it's not because I'm ignoring you, it's because I really can't see you. So shout it out, let me know. I'm happy to discuss any of this. What does NLP, natural language processing, have to do with you? Okay, well, first off, we all started with some great rudimentary NLP, right? For those, it's kind of fuzzy. Misfortune strikes and you have fallen into the moat. Your struggles and cries have attracted hungry alligators. They do not want to let you go. What do you do now? Right? That's where we started with video games, right? It's all text. I mean, I remember, playing video. There weren't any pictures, right? It was just, you have reached a room. There is gold in it. What do you do? What do you think I want to do? I want to pick up the gold, right? But that's where we started, right? We started with exchanging. And now we have we have video games that talk to us. We can talk to them. They talk back, right? There's some awesome multiplayer games out there that are really kind of pushing the boundaries with what you can do in terms of interacting with the players, the NPCs in there. And there are a lot of aspirations for video games where they want to have, NPCs that are very much things that you can exchange banter with. You can come talk to them, get information, that type of thing. So there's a lot of NLP that goes into that. Obviously, Google's got the lockdown, right, on NLP. They want to be able to answer all your questions before you even ask them. And it used to be, right, you had to get sort of schooled in Googling, right? You had to go and be like, all right, what do I have to put in there to get the thing that I want out, right? And now they're just providing you the answer. You don't even have to find the links. You don't have to scroll through, right? So they are making great strides in question answering and in interpreting what the user actually wants to be able to provide you with that information. Intelligence, okay? So you see all those shows, CSI, Alias. I'm not sure what you guys watch around here, but all these shows where they're getting, information about bad guys and that sort of thing, all of that comes from some manner of NLP, right? There's so much information that's coming in. They have to have ways of analyzing it, of finding relevant pieces of information, right? Without having to dive through it, without having interns reading every spec and then providing useful stuff on down the line. Obviously, Siri, things like that, right? You talk to it, it responds, it gives you what you want. There's so much stuff that goes into something like that to be able to provide that information that we sort of take for granted, right? And we'll be going through some of those challenges as to what is hard. Why are these hard problems that people are trying to solve? And then why is it that we get so frustrated with some things? And hopefully you'll understand a little more about why these things are not as seamless all the time as you think they should be. All right, so the main areas of NLP. These are my main areas. You can't go out and, find somebody else quoting these. These are just sort of what buckets I've put them in, all right? Optical character recognition, OCR. So that is taking text, so something that is, taking like text, handwriting, something, whatever, and turning it into digital, okay? So if you have written a note out, right, and that's coming into some of the things that you want to do, right? There are a lot of, OneNote and stuff like that where you can write on it, and it will translate that into text for you, okay? So that's what OCR is. Voice recognition, right? Being able to hear what you speak and translating that also into text so that the computer can understand it and start to be able to analyze it. Language generation, okay, so that is being able to spit out language, right, all by itself, right, which is actually a very hard problem. It's hard for us humans to sometimes spit out language that is coherent, right, and we're asking a computer to do that as well. But there's a lot of work that's going into language generation these days. question answering, right? That's what Google does. It's what a lot of people do now because there's a lot of money in that, right? We want to be able to answer exactly what your question is, but in order to do that, we have to know what your question is and what the intent is behind it. Machine translation, the world's getting smaller, that's what I hear, right? And a lot of people's goals is to make it as seamless as possible to bring people together and be able to translate between languages, since we, well, especially us in America, we seem unwilling to learn everyone else's language. So, we're just going to have Google do it for us. Not me. I speak all the languages, so you can't look bad on me, all of them. Information extraction, that is pulling out pieces of information from text. So say you're reading a news article, right? It might pull out who the news article is about and relevant pieces of information to provide those to you in a summary or something like that. And knowledge representation, okay? So that's a lot of the stuff that we're doing sort of with the semantic web or whatnot. That is how we are representing knowledge in a way that the computer can understand it, right? Because it's not enough to be able to just understand the words that are coming out, but you have to also understand the meaning underlying that. So what are we actually talking about, not just what words are we using? All right, so this is if you don't get anything else out, this is sort of the meat of the presentation, because what I want for you guys to get is why is this hard? Why are these problems hard? Okay? If you're a computer and you get fed a bunch of this, right? And somebody's like, go interpret that, and you're like, well, F that, right? We are like that, right? How many of you can read your own handwriting? I can't see you, so I think that's none of you, right? And yet we want a computer to understand that. We want to be able to scribble whatever we want and be like, hey, you go read that and do whatever it is I said, right? Not only that, but you think also about how we write, okay? So if you're writing notes, are you writing complete grammatical sentences when you're writing your notes? Does your doctor, when he's writing notes about you, write complete grammatical sentences that everyone can understand? When you tweet, when you email, when you do anything, unless you are writing a blog post or an article, are you writing good English? Chances are no, right? Chances are that you're writing really short snippets, you're leaving out words, you're writing stuff that only you understand, right? But all of this stuff is being consumed digitally now. It used to be that it's just, you had all your notebooks stacked up on a shelf thinking you're going to go back through them, right? We don't do that anymore. Everything is digital, and we want everything searchable. We want everything understandable, right? And we want it all done by a computer. And yet, we want it to understand all of this stuff, okay? When we're talking about voice recognition, all right, we got people with high voices. We have people with low voices. We have people with everything in between. We have people who speak very slowly. We have people who speak very fast, right? So much variation in the way that we speak. And not only that, but also the languages that we use, right? Add on top of that accents, okay? This is sort of a representation of accents in the US. Every country has something like this, right? You can tell where someone's from by the way that they're speaking. But if somebody in the North has issues or problems understanding somebody with a strong Southern accent, like my cousins in Whitmire, right? We're also expecting a computer to understand all of those accents, right? Or non-native speakers, if you've got a strong, heavy accent when you're speaking whatever language you're trying to go to, right? You want the computer to understand you. So this is a really interesting graphic. Some data scientists went out and they did a study, and they looked at all the languages that were being translated, or I guess all the stuff that was being translated on the web, and what it was being translated from and what it was being translated to. So the lines represent the numbers or the amount, okay, of translation between languages. So the one, I can't point, so you guys are just going to have to follow my directions. The one in the middle is English. The one on that side is Russian. The one on the bottom on this side over here, the blue one, is French, and right above that is Spanish. Those are sort of the main ones that I guess are being translated. But you can see from this not only sort of what the main translations are, but just the volume of translations and the volume of languages that are out there that are being translated, right? So again, we're just adding onto the complexity that is language in general, right? That we are trying to encode into these models that we want to use to be able to produce AI, right? If we've got a robot who can't speak multiple languages, then what good is it, right? It's not doing us any good for the things that we wanted to do. So I thought this was a really interesting study being done, but it also shows, again, all the sort of different facets that's going on. So, other challenges, okay? So my background is I have a master's in linguistics and a PhD in computer science. So I sort of marry the two worlds together. So I have a lot of understanding about theoretical linguistics, and then I have a lot of understanding about theoretical computer science. So linguistics is broken down into a number of different areas, right? We have phonology, which is the way that we pronounce our words, okay? We have morphology, which is the way that words are put together, okay? We have lexicon, which is sort of just our words. Then we have syntax. Syntax are the tree diagrams that you guys used to do in school, right? We've got verbs and nouns and, and then we've got semantics, okay? This is what this points to. Semantics is what do you mean by your sentence, okay? So, when you get something like this, I want to know the meaning of life, right? There's a lot of interplay there, right? What do you mean? Do you mean the actual meaning? What does the word life mean, right? Or are we talking about something higher up, right? So that's semantics. And then pragmatics goes a step further. Pragmatics are the really underlying meaning. So if your kid is walking out the door and you say it's cold outside, right? What are you likely meaning to him or her? Maybe they need a coat, right? And we say things like that. Oh, it's raining outside, to mean go put on a raincoat or go get an umbrella. But we don't say that, and we don't even come close to saying that, right? So trying to explain to a computer the underlying intent or the inference that they need to make from these statements is sort of the holy grail of natural language processing, right? Because how do we take these two sort of innocuous statements that by themselves mean something, but then we have to infer something kind of completely different from the context that we're given, right? And then the last thing we have is ambiguity. Okay, and we, especially in English, are fraught with ambiguity, okay? Everything means possibly multitude of things, right? That's where a lot of our jokes come from, right? Is ambiguity. All you guys out there laughing, I know what you're thinking. I got your number. All right, so these things, we can, as humans, read them and decipher them, even though they are not quite great grammatically, right? And yet, once again, we have to provide this stuff to a computer and have them figure it out, right? So taking this ambiguity and turning around, one, making the computer aware of it, being like, hey, there's a lot of different ways statements can be taken, and then getting it to look for it, and then getting it to find it successfully. That is a super hard problem, right? It's a lot of stuff about language that we sort of take for granted. All right, so where are we at now? So it used to be that we had all these sort of rules-based systems. That's where we started out, right? So we were like, if so-and-so says this, then you need to respond with something like this. Or if this happens within a sentence, then you need to do this, right? And that's how we started out. There is still a problem with trying to put together a complete grammar for the English language. It hasn't been done. As far as we can tell, it's just infinite. You can make up infinite number of sentences and infinite number of ways, and they could just go on forever. So trying to put that into a concrete system that says, okay, these are all the rules for English for creating grammatical sentences has not been accomplished. So lately, we've gone to a shift towards statistical NLP, and that basically came with all of the data that we started collecting. So we started collecting data, we started collecting more data, and then we're like, hey, let's just use all this data to let the computer figure out what it needs to do, right? So machine learning, data, all that came together. And now, obviously, we're moving to deep learning because that's where everyone's headed. More data. Again, we have lots of data to support all this stuff. So deep learning is sort of being used to try and say, okay, we're going to let the computer just figure out the high-level abstractions of language, right? So use all this data and look at it and try and figure out sort of what is the underlying stuff that makes up language. So for machine translation, essentially what they started out doing was, again, with the rules-based system, saying, okay, translate, we'll go word to word, we'll do this sort of thing. And then they started taking parallel corpora. So we're going to take this book in English, and we're going to take this book in Norwegian. We're going to essentially use the computer to map how this fits together. And we're going to create a model that will then be used to do more translation on other things between those two languages. So that's sort of where we started. And there's a number of techniques there's a lot being done in machine translation. So syntax-based, again, that's the way that our sentences are made up. So is it, subject, verb, object, or do we have a subject, object, verb, syntax? Phrase-based. Phrases are the little pieces of language. So like in the car is a phrase or something like that. So looking at pieces rather than just word to word. Word alignment, again, that was what I was talking about with the parallel corpora. So saying, okay, well, where does this word in this book fit with this word in this book? How are they matched up? And language modeling, so being able to take a whole bunch of some language and put it together and try and model that to be able to do more translation. And sort of the state of the art right now is neural machine translation, unsurprisingly. So essentially doing neural networks to do the machine translation. Language understanding. So not surprisingly also, Google and Facebook sort of are the forefront of language understanding. And they are uniquely motivated to be there, right? They have tons and tons of customers who need them to understand what they are talking about. So Google wants to be able to provide you everything you need, whether it be an ad, whether it be a link, whether it be whatever, email, suggestions. And Facebook is also trying to jump into that arena. They want to understand your posts so that they can recommend that you go buy something based on your need for a mattress or something like that, right? Or group your posts together, whatever they want to do with them. So Google put together a system called Word2Vec because one of the biggest problems in natural language processing is representing words for the computer. Computers are numbers, right? Everything a computer does is based on numbers. So how do we translate the words, the letters we have, into numbers? And it used to be we just used characters and that sort of thing. Well, Google basically came up with this idea of representing every word as a vector. And they can do it because they have tons and tons of data to lean back on. So they used all this data, they fed it into a machine, and they had it come up with word vectors, which they found had some interesting properties, okay? So they found some basic things that if you took the vector for the word queen, that it was roughly equivalent to taking the vector of the word king, subtracting the vector for man, and adding the vector for woman, which is a really interesting finding, right? they are now finding that these vectors kind of represent the underlying meanings of the words that they're representing. And that's because the vectors are based on a larger context, right? So they find that queen and king are coming up in similar contexts, right? That they are used in the same ways and are talked about in the same ways. Facebook did a system, and this was a couple of years ago, but they basically fed it a whole lot of the Lord of the Rings text. And they just were like, okay, well, let's see what it'll do. So they started asking it questions, and they gave it a series of questions, like, or they gave it a series of sort of state of being within the Lord of the Rings universe, and then they asked it questions, and it could tell you, based on what you gave me, that, Frodo is in the Shire, and that the ring is, with Sauron, and that type of thing. So they were finding that the computers, if you give them enough context, are able to make some inferences about that. And then most recently, they came out with deep text. That was only in the last month or so. And that's what they're sort of using underlying all of their Facebook, magic in terms of trying to understand what your posts are about and the context that they are in. And so they're sort of pushing the forefront on language understanding. So I throw in neuromorphic computing. It's a hobby of mine that I follow a lot. But neuromorphic computing talks about sort of the area that is trying to mimic the brain with our hardware and our software architectures. And I guess the most famous one is IBM's True North chip. And it has 5.4 billion transistors with 4,000 cores. And 1 million neurons. It mimics 1 million neurons and 256 synapses, okay? That is like the tiniest part of our brain. But it's a step in the right direction. And what they're trying to do is they're trying to make our computation mimic what our brain does, because our brain is low power, right? And huge amount of information storage and access and computational power. So I guess in terms of NLP, what we're doing is starting to map deep learning onto some of these chips, which I think is a really, really interesting breakthrough and a really interesting area to go into, because our language comes from our brains. So I will be really interested in the future to see sort of how that progresses and where we're going with it. So likely, you've all heard of the Turing Test, okay? Alan Turing came up with it in 1950, and he said, okay, essentially, I'm going to say that computers have sort of become, human-like once they are able to fool human interrogators 30% of the time into thinking that the computer is human, right? Which is an interesting concept, right? And it sort of stayed for a while, because in the 1950s, that was a huge, lofty goal, right? But that was passed by a chatbot in 2014. Lots of people are doing chatbots specifically to beat the Turing test, but there are other applications, right? But the question then it becomes, is this still a good test of artificial intelligence? Right? Is creating a chatbot that can fool a person into thinking that it's a person, is that true intelligence? In my mind, I think sort of we have to go a step further, right? And there's other criteria that we could look at in terms of like memory storage and architecture flexibility and the way that we're using computers. But I had a thought and I lost it. It'll come back to me, I think. But it's interesting to think about what we have done in our quest to solve this test, right? So if you think about some of the things that you talk to, so like if you go and call your bank, right, and talk to the obviously artificial person there or whatever, there are things that we have done to try and pass the Turing test that maybe aren't very useful, like adding a pause to make it sound more believable, right? Is adding a pause to make it sound more like a human, is that actual intelligence? Or are we now adding features to our chatbots to get them to sound more human that are really, really not useful to be adding and probably not a little bit of a waste of time, right? So Google Brain, Google again is sort of at the forefront, and I am so jealous of some of the stuff that they can do. They have tons and tons of resources and tons of data. But Google Brain is a deep learning research project and group at Google. And their whole goal is to accelerate machine learning research, which is such an ambiguous goal, but that's sort of the beauty of it. They sort of basically give them money, and they're like, go study whatever you want with this goal in mind. And the researchers at Google Brain get to do just that. They get to sort of play around. They have a neural net that recognizes cats. Why? I mean, I'm sure that there is a very good underlying reason and that sort of thing, but they get to just go and play. And I think sometimes that's important, right? It is important to not just have business goals to be able to accelerate research. And some of the stuff that has come out of that, they are able to do much more in photo and image recognition, much more in machine translation and improved search just based on some of the stuff that has come out of there. So personal assistants. This is sort of, in my mind, one of the biggest things that has been going on in AI in the last few years. It's interesting to me, right? We've got all these ones, Siri and Alexa and Cortana and that sort of thing, right? That's what everybody felt like was going to be the thing, right? You were going to have an assistant who could schedule your meetings and interact with other people's assistants to schedule meetings for you and be able to go and buy flowers for your wife and go and, get you a car and all these things, right? It was going to be able to do that. How many people's assistants can? Again, I can't see you, so I'm assuming nobody's, right? If you do, I want to know because I want in on that. But that was sort of the goal. And how long have we had assistants? We've had them a while. We're not there, right? Most assistants are still just, what's the weather? What's the traffic, right? Hey, what's this song that I'm listening to, right? Play me some jazz, Alexa. My daughter constantly asks Alexa to play Hamilton for her, which is fine, except our Alexa doesn't have Hamilton on it because we have not loaded that on there. So she ends up getting 30 seconds of each song, which is like Alexa's way of trying to sell you, something. They're like, oh, I found this snippet. So it'll play like 30 seconds of song, and then it'll be like, oh, and here's the next song, 30 seconds of song. So I end up hearing the first 30 seconds of every Hamilton song over and over in my house. It's been interesting where the personal assistants are going. Facebook came out with Facebook M, which lasted all of maybe a year and a half, but it was going to be this breakthrough thing. They even had a sort of human in the loop where they had the digital part that you could ask things for, and then if it got too hard, it would sort of pass off to a human who would then go do it for you. And their idea was to let it learn over time to where that would eventually go to the digital part. And then all of a sudden they were like, oh, nope, we're done. Sort of the only remnants of M that are left are when you're in Facebook Messenger and you're like, let's go to the movies. And Facebook's like, let me get a car for you. And you're like, no, Facebook, stop trying to suggest things for me, right? Google Duplex came out, interestingly enough, recently. And it is sort of an audio version of that, and they're starting to use it like in a hair salon to book appointments and stuff. And they've had some success in people not being able to tell that it's not a receptionist. So that's an interesting move. But essentially, they're using more and more data to try and improve performance, but we're not anywhere closer to having an assistant that's going to do all the things for you. Social robots, okay? So I think Japan's kind of got the lockdown, right, on the social thing. They've even got, I saw recently, you can book somebody, if you can't go into the office, to wear an iPad on their face and then have you projected out, and they'll go around to your meetings for you, right? So they try very hard to not have to go anywhere. But it's interesting, I think, from a psychological perspective. You look at this picture, there's a robot, a clear little robot, and then there's a person-looking robot, and then there's a dinosaur-looking robot, right? And you can sort of pick which one you want to go to. Do I want to go talk to the dinosaur today? They're going to underlyingly have the same tech, right? You're not going to get a different thing from the dinosaur robot than you are from the person robot. But people have different feelings about robots and what they look like, okay? So from the psychological side, there's been a lot of studies done on the way that people feel about robots. So somebody did a test, and they have these little dinosaur robots, right? Probably looks like that, but smaller. And they gave them to people, groups of people, and they had them interact with them. They had them name them, okay? And then they had some more interaction. And then they asked people to destroy them, okay? Keep in mind, this is a bunch of wires with a shell on it, right? But if the people had named the robot, they were unwilling to destroy it across the board, right? It didn't matter that this was a toy that they were interacting with. Once they named it, we sort of anthropomorphize everything, right, as humans. And so once they named it, they had issues getting rid of it. Likewise, okay, they did a test with an emergency robot. So this robot was supposed to help you in case of emergencies. Supposed to lead you to safety, give you information. So they had one group where they introduced the emergency robot, and they had it do a test, and it did it fine, okay? And then they had another group of people where they gave them the emergency robot. They had to do the test, and they gave it a glitch. So if the sirens went off, it would go off into a corner and bump in a corner or something like that, right? Or it would tell them to do the wrong thing. After that, they then actually simulated an emergency. They set off the fire alarms or whatever, and found that regardless of whether or not the robot had been demonstrated correctly, that people would follow the robot 70% of the time. In fact, they found that people would follow the robot into a darkened room that was partially blocked by furniture and wait for the robot to tell them what to do, even though it had been demonstrated that this robot was faulty, right? So it's interesting to think down the line how we're going to interact with robots, and I think language is a big part of that, right? We're going to have to get the language right, because otherwise we're just going to be blindly following these bad robots. So this was an example that I thought was interesting. The other thing about robots is the way that they look, right? And we have this, there's a name for it, and I don't remember, but there's a phenomenon about robots looking too human, right? But they did this one in Singapore, Nadine, and she talks to her creator, which I thought was interesting.
Hello. Nice to see you. What is your job? I am a social companion. I can speak of emotions and I can recognize people. We're officially the Republic of Singapore and often referred to as the Lion City, the Garden City, and the Red Dot is a leading global city-state and island country. You are beautiful. Thank you, Nadia. I think you look attractive too. I recognize you're Nadia. Nice to meet you again today.
So I find that clip really fascinating. Number one, there is a clear back and forth, right? Their creator is obviously interacting with her. That robot in particular is able to recognize facial emotions and respond to them correctly, as you saw when she said, "You're very pretty," and she said, "I find you very attractive also," right? So giving back appropriate responses. But there's still that weirdness, right, that is odd when it looks fairly human. Somebody down on the floor has a robot, right, that's just like a little white thing with a screen, right? And you don't find that one half as odd if it talks to you, right? So there's this sort of interesting idea that do we try and go closer to human because that's what we're trying to get with AI, but yet it's odd, or do we kind of pull back and go to these other robots? No. There we go. All right, so where are we at and where are we going? For me, I think largely there is sort of this line that we have to figure out. Where do we go from analyzing data so much that the computer knows things? Kind of like Watson with Jeopardy, right? Did that computer, when it was going through its huge banks of data and pulling out the questions to the answers, right? Did it know those things? Or was it just finding information and data? And what point does a computer know something versus just analyzing that data? I would love to say that we're headed towards some great breakthroughs in NLP and we're going to have, a speaking robot any time now. I don't think that's the case. I think largely what we're going to do is sort of move along that line of personal assistance. We're going to have, they're going to suggest to you what pictures you should put in your presentation based on the content that they have. They're going to suggest attachments to your documents based on the content of your email, doing more automated fact-checking and resume screening. I think those are the things that we're headed for in the near future. I think there's a lot of stuff that has to come together to be able to get at actual AI. And I think we're headed a lot more quickly towards automatic translation, which I think is a great, something that would be awesome. So if you want to get into, on the action of AI, this is not an exhaustive list. In fact, it's a very small list. I picked some of the big ones, right? But go out, find a framework and find something that you can get started with. Google's TensorFlow or OpenAI or Microsoft's AI or cognitive services, right? Go play with that. If you are very interested in actual NLP, I would start with something like NLTK, which is sort of a really basic getting started with some parsing and some chunking, and they can do all rudimentary NLP. So NLTK would be a good one. But I suggest, just go out there, see what's going on, do some research, and get started. So this is my contact information. If you're interested in finding out more, talking, I am always willing to have conversations, collaborate. I love talking about what I do, and I love sort of sharing it with people and having further conversations. There's no way that any of these problems are going to get solved, by just a handful of people. It takes a village, right? So, look me up. I'm on Twitter, but I don't really do anything on Twitter, so you can find me and then not get any tweets. And I am more than willing to have any questions or comments or debate. I can argue with the best of them.
I've got a question. You mentioned that you use machine learning. Have you also been able to look inside the machine at nearly the end and find something about mostly used grammar rules or often used sort of sentence structures that are perhaps that linguistics might not have found yet?
Yeah, so his question was, since I use machine learning, have I been able to sort of look into the black box that is machine learning and sort of pull out sort of oft-used grammar rules or any other insights that sort of hadn't been known before? For me, that's one of the big drawbacks of machine learning, and especially deep learning, is there is, generally, you put stuff in and you don't get great stuff out. And especially with stuff like Word2Vec, right? You can sort of analyze those as Google did on the outside, but once you pass them in as sort of inputs to your system, what you get out is not normally usable. There is a lot of research that's being done right now on trying to be able to pull out more information from neural nets. They do it really well with some things like image recognition. You can pull out pieces, and you could tell what different neurons in the neural net are essentially focused on in terms of image, but that's really hard when you get into something like a word to vec or something like that. So I could see that as being sort of something that comes in the future because it's definitely necessary, but right now there's not a lot you can do with it. Well, then that's all I got. And I have cards if anybody wants a card. Sometimes those are easier than writing down information.